Okay, the empirical formula is the simplest ratio of atoms in a compound. So if you can simplify subscripts, then you do, and you would get the empirical formula. So if you look at student exercise 14, they give you C6H12O6. You can simplify the subscripts to get CH2O. So CH2O would be my empirical formula. Okay. The next example is H2O. Sometimes the substance that you're given is already written in simplest form, which is fine, and that means that the empirical formula would be the same thing. So here, my empirical formula is also H2O. H2O2, or hydrogen peroxide, is the next example. This can be simplified to HO. And the last example is C4H10. C4H10 can be simplified to C2H5. Okay, now we can also calculate the empirical formula by using a series of steps, and those steps will always be the same. They're typed up for you in your chapter handout. And I'm going to go through those steps in student exercise 15. Okay, so student exercise 15A has given you a 6.5 gram sample of powdered chromium. So I'm going to write down 6.50 grams of chromium. It's heated with pure oxygen, and the compound that we make has a mass of 9.50 grams. What is the empirical formula? You need to have the mass of every element in the compound in order to calculate the empirical formula. So if I want to get the mass of oxygen that's in the compound, I need to subtract the mass of the compound and the mass of chromium in the compound to give me my mass of oxygen, because chromium was combined with oxygen to make my chromium oxide compound. Okay. Now, you will never have diatomic elements in the compound when you're calculating the empirical formula. This is important to note because we have elements when they're pure that may be written with a subscript 2, which are those diatomic elements, but here that will not be the case. Okay, so when we have the mass of the elements that are in the compound, you have to convert the masses to moles first. So the first step is convert grams to moles by dividing by the molar mass. Okay, so I set up my little grids. The mass of chromium, the molar mass of chromium on the periodic table is 52.00 grams. So I'm going to set it up like this. Okay, and when you divide that out, you're going to get 0.125 moles of chromium. You don't want to round off moles to the proper number of significant figures. You want to write out maybe 5 places past the decimal, because if you round, it may affect the simplest formula that you get in the end. Okay? All right, now oxygen has a molar mass of 16. Keep in mind that this is not pure oxygen, it's not diatomic, so that's why it's just 16 instead of 32. So when you divide 3 by 16, you're going to end up getting 0.1875 moles of oxygen. All right, now once you convert grams to moles, divide by the smallest mole, which is 0.125 in this case. And after you divide by the smallest mole, if the numbers that you get are within 0.1 of a whole number, then you can stop. So examples of being within 0.1 of a whole number would be like a 0.9 or a 0.1. Okay? So here, I am not within 0.1 of a whole number. So you're going to multiply by whole numbers until you are at a whole number, and multiply by the whole number that is the most logical. Like if I take 1.5 by 2, won't that give me 3? Doesn't that give me a whole number? So that's why we're going to multiply by 2. which will give me 3, okay? So since I multiplied this by 2, I have to multiply this by 2 as well. So 1 times 2 is going to give me 2. The numbers that I just circled are my subscripts for my empirical formula. So my empirical formula will be Cr2O3. And that's it. You're done. Okay? Okay, now let's do another example that's just like this. It is exercise B. Exercises A and B are very similar to empirical formula problems that you would get in a lab based on empirical formulas. Okay, so that's why we're doing them. So in B, you have 1.75 grams of tin. So I'm going to write 1.75 grams of tin. It's reacting with bromine to produce a compound with a mass of 4.10 grams. So I'm going to take 4.10 grams, which is the mass of my compound produced. I'm going to subtract 1.75 grams of tin, which is going to give me 2.35 grams of bromine, like this. That's in my compound that I made. Once you have the masses of each element in the compound, then you can convert grams to moles. So we're going to divide by the molar mass of tin and the molar mass of bromine separately. Tin has a molar mass of 118.71 grams. And when you divide that out, you're going to get 0.01474, and I'm not rounding, I'm just writing like 5 places past the decimal. And then the molar mass of bromine is 79.90 grams. So we're going to divide that out, and we're going to get 0.02941 moles. Okay, again, I wrote it like 5 places past the decimal and I didn't round. Okay, once you convert grams to moles, now you can go ahead and divide by the smallest mole. So the smallest mole here is 0.01474. Once you divide each mole by the smallest mole, if you're within 0.1 of a whole number, then you can stop. So here I have a whole number 1. Here I am within 0.1 of a whole number. Remember I said if it's a 0.9 or a 0.1, then you can round that to the nearest whole number, and those are the subscripts in the empirical formula. So the numbers that I just circled are the subscripts in the empirical formula. So I have Sn, and remember we don't write the number 1 as a subscript, so it's Sn Br2. And that's your empirical formula. Okay, let's do one more example where they give you percentages instead of grams to begin with. So if we look at C, it says that we've got 39.10% carbon. When you have percentages, drop the percent sign and just place a little g after it. It's going to really be grams. Okay, so percent and grams are equivalent to each other. So 39.10 grams of carbon. And then you have 8.77% hydrogen, which is really 8.77 grams of hydrogen. And then you've got 52.13% oxygen. So 52.13 grams of oxygen. Okay? Now you want to convert grams to moles, so we're going to divide each by the molar mass. Keep in mind that all of these substances are not pure, so don't make the molar mass of hydrogen and oxygen what it would be if they were diatomic, because these are all in a compound, okay? Okay, once you convert these to moles, you're going to get 3.2556 moles of carbon, and you're going to get 8.6831 moles of hydrogen, and 3.2581 moles of oxygen. So it'll look like this. Now you're going to want to divide by the smallest mole, which is 3.2556. So divide each mole by 3.2556. And you're going to end up with 1 here. And then here you're going to end up with 2.667, and here you're going to end up with a 1. Now, 2.667 is not within 0.1 of a whole number, so you need to multiply by a whole number until you get there. So if you multiply this by 2, it's not going to help you. So go to the next whole number. Multiply it by 3. So 2.667 times 3 is going to give you 8.00. So now I am on a whole number. So since I multiplied by 3 here to get to a whole number, you have to multiply this by 3, and you have to multiply this by 3. So your subscripts are going to be 3, 8, and 3. So this is going to be C3H8O3 for the empirical formula, like this. And you're done. Okay? Now you can go ahead and do the worksheet titled Empirical Formulas.